Good morning, students. Today we will start with our first unit of the paper 3, that is topology. First we will know what do you mean by topology. Topology contains two Greek words, that is topo and logy. Okay, it's a combination of two words. Topo means surface and logy means study. So it is nothing but the study of the surface. Once you hear the meaning of the topology, that is study of surface, you will come to know it's a geometry. Okay, surface means it's a geometry. But to study this one, to know what do you mean by topology, we should know the set theory. Okay, by the set theory we will understand what is the property hidden this. Okay, so topology definition is it's a mathematical study of geometrical properties that are preserved through deformation, stretching, and twisting. Here it's one of the geometrical property. It studies the geometrical property. Which property is that? It is preserved, means it is not changed when we deform or stretching or twisting of any object. Okay, for example, if you take a circle, when you stretch this horizontally you will get the ellipse. So here, according to topology, the geometrical property of this and this is same in topology. Okay, next, when you take a sphere is same as circle only with the 3 dimensions. Circle is a 2 dimension, sphere is a 3 dimension. When you stretch this one horizontally, you will get a ellipsoid. Okay, here also according to topology these two are equal. These are all what are the main purpose of the study of the topology. Okay, but in your syllabus you have basic introduction of topology, that is you are going to know about the topology using set theory. For that we will just glance the basic concepts in set theory. So set theory you have already studied in the third semester. Just we will revise one by one. Set is a well defined collection of distinct objects. Okay, sets are usually denoted by capital letters and elements of the set are denoted by small letters. So A is equal to some A, B, C, D. So this is a set, any set. Okay, next is finite set. A set which contains finitely many numbers, then that set is called finite set. Okay, so for example, set of alphabets in English. Okay, or A is equal to some 1, 2, 3. So it's a finite set. If a set contains infinitely many elements, then that set is called infinite set. So for example, set of natural numbers. Okay, next is empty set. Empty set is also called as null set. So null set is usually denoted by flower brackets or phi. So it has a set which has no element is called empty set. Next is singleton set. A set which has a single element or one element is called singleton set. So here A is a singleton set. B is a singleton set. Okay. Next is subset and superset. Subset and superset. Okay, if A and B are any two sets, if every element of A is in B, then A is said to be subset of B. Okay, that is every element of A should be in B. Whatever in B, it should not be in A, but every element of A should be in B. Then A is subset of B. Here A is subset of B, and also B is superset of A. Okay. Next is proper subset. If A is subset of B and B contains at least one excess element than A, then it is called proper subset of B. A is proper subset of B. So we'll see example for subset and proper subset now. If A is equal to some 1, 2, 3, B is 0, 1, 2, 3, 4, then A is subset of B. Okay, one extra element here, it is having 1, 2, 3, here one extra is there, so you can say that A is proper subset of B. Okay, ಅದೇ equal ಇದ್ರೆ you have to say A is subset of B ಅಂತ. Either it may be equal or greater, means having more number of elements than A, but here it is having at least one extra element, that is B is having one extra element, therefore A is subset of B. Next is equality of sets. So when you say two sets are equal, if every element of A is in B and every element of B is in A, then you can say these two sets are given sets are equal. Equality of sets. If A and B are any two sets, if every element of A is in B and every element of B is in A, then we can say that A and B are equal sets. If A is equal to B, that implies A is subset of B and B is subset of A. To prove equality in sets, we use this rule, that is A is subset of B and B is subset of A. Next is comparable sets. If A and B are any two sets, either A is subset of B or B is subset of A, then A and B are said to be comparable sets. Okay. Next is non-comparable. Non-comparable sets. If A and B are any two sets, neither A is subset of B nor B is subset of A is called non-comparable sets. Next is family of sets. If A is any set, it contains the elements such that all the elements in that are also sets, then that set is called the family of sets. Okay, it's a family of set. One more example I'll give. AB, ECD. Okay, so this is the family of set because all the elements in the set are also sets. Next is power set. If A is any set, power set is denoted by P of A. P of A is the, for example, A is equal to 1, 2. Power set of any set is contains all the subsets of given set. Okay, so here all the subsets of set A are singleton set 1, singleton set 2, 1 2 itself is a subset, and 5 is always a subset of any set. So it contains 1 singleton 1 2 1 to 5. Okay, for any set A having n elements has 2 raised to n number of elements in the power set. Okay, so here A is having 2 elements, so 2 raised to 2 4 elements. Okay, next is universal set. While dealing with the set theory, all the sets what we consider are subset of some fixed set. That fixed set is called universal set. Universal set are usually denoted by letter U. So for example, if you take A as some 1 2 3 4 up to 10, okay, then you can take it as set of natural numbers, fixed set it is. Okay, next one, union of sets. If A and B are any two sets, then union of A and B is denoted by A union B. It contains the elements which are either in A or in B or in both. Okay, so here A union B is X, where X belongs to A or X belongs to B. So either should be is in A or B. ಎರಡರಲ್ಲಿ ಒಂದರಲ್ಲಿ ಇದ್ರೂ ಇದರಲ್ಲಿ ಬರುತ್ತೆ. Okay, for example, A is equal to 1 2 3, B is equal to 0 minus 1 8, then A union B will be minus 1 0 1 2 3 8. Okay, next is intersection of sets. Intersection of sets. If A and B are any two sets, intersection is denoted by this symbol. It contains the elements such that it should that element should be in A and B. Okay, for example, B is equal to 1 3 5 7, then A intersection B will be 1 3. Okay, next is disjoint. ಸೊ ಡಿಸ್ಜಾಯಿಂಟ್ ಮೀನಿಂಗೇ ಇದೆ. ಜಾಯಿಂಟ್ ಅಂದರೆ ಕೂಡಿರೋದು, ಡಿಸ್ಜಾಯಿಂಟ್ ಅಂದರೆ ಎರಡು ಸಪ್ರೇಟ್ ಆಗಿರೋದು. ಓಕೆ, ಟೂ ಸೆಟ್ಸ್ ಎ ಆ್ಯಂಡ್ ಬಿ ಆರ್ ಸೆಡ್ ಟು ಬಿ disjoint sets if there is no common element between these two sets. That is, A intersection B is a null set. Then we can say that the set is the two sets are disjoint sets. Okay, so for example, A is equal to some A B C D, B is E F G, then A intersection B will be a null set. Therefore, A and B are disjoint sets. Difference of sets. Difference andre ಏನು? Difference andre minus. Okay. So it is difference of sets. That A and B are any two sets. Difference of A and B are the set of elements which belongs to A but not belongs to B. Okay, denoted by A minus B. So these are the elements such that that elements belongs to A and not belongs to B. Similarly, you will have a difference of B minus A also. Okay, B minus A is, these are the set of elements which belongs to B but not belongs to A. So example, B is equal to 4 1, then A minus B will be what? A minus B will be 2 3 5. Okay, and B minus A is what? B minus A is null set. Next, complement of a set. So if A is any set, okay, its complement is denoted by like this, A raised to C or A dash. It is like reciprocal. Example, so these are the complement of a set are the set of elements which of universal set U which are not in A. So example, let U is equal to set of natural numbers. If A is set of odd numbers, then A complement will be, it is U minus A. These are the set of elements in U which are not in A. U minus A. So it is U minus A means natural numbers only odd numbers tagidre you will get a even numbers, set of even numbers. Next, intervals. We will study what do you mean by open interval, closed interval and all that. Okay, intervals. So this is important for the topology. Okay, for any two real numbers A and B, real numbers A and B with A is less than B, open interval means open interval from A to B means it is denoted like this, open interval. So this is this contains the elements such that the elements should be between A and B. Okay, not including A and B. These are the set of real numbers which are between A and B. Okay, ಈಗ ಇದು ರಿಯಲ್ ಲೈನ್. ಓಕೆ, ರಿಯಲ್ ಲೈನ್. ಇಲ್ಲಿ 0 ಇದೆ, ಇಲ್ಲಿ A ಇದೆ, B ಇದೆ. Okay, such that A is less than B. Okay, real numbers. Now, so X is anywhere here. So if it is open interval, okay, like this, all the elements ಎಕ್ಸೆಪ್ಟ್ ಎ ಆ್ಯಂಡ್ ಬಿ ವಿತಿನ್ ದಿಸ್ ಇಂಟರ್ವಲ್. ಓಕೆ, ಇಲ್ಲಿಂದ ಇಲ್ಲಿವರೆಗೂ ಬರೋ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸು ನಾವು ಓಪನ್ ಇಂಟರ್ವಲ್ ಎ ಬಿ ಇಂದ ಡಿನೋಟ್ ಮಾಡ್ತೀವಿ. ಸೊ ದ್ಯಾಟ್ ಇಟ್ ಡಸ್ ನಾಟ್ ಇನ್ಕ್ಲೂಡ್ ದಿಸ್ ಎ ಆ್ಯಂಡ್ ಬಿ. ಓಕೆ, ಇಂಟರ್ವಲ್ ಪಾಯಿಂಟ್ಸ್ ಇದೆಯಲ್ಲ, ಇದೆರಡೂ ಬಿಟ್ಟು ಇದ್ರ ಇನ್ ಬಿಟ್ವೀನ್ ಬರೋ ಎಲ್ಲ ಪಾಯಿಂಟ್ಸು ಇದರಲ್ಲಿ ಇನ್ಕ್ಲೂಡ್ ಆಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಇಸ್ ಕ್ಲೋಸ್ಡ್ ಇಂಟರ್ವಲ್. ಫ್ರಾಮ್ ಎ ಟು ಬಿ is denoted by the square bracket. So these are the elements in the region in the interval a and b. ಅಂದರೆ ಇದೇ ಸೇಮ್ ಇದೇ ಎಕ್ಸಾಂಪಲ್ ತೊಗೊಂಡ್ರೆ including a and b here, square bracket, that is closed interval means these are the elements in the interval. These are the real numbers in this interval including a and b. Next is semi open interval from a to b. semi open ಅಂದರೆ half open, one side open, ಈ ಕಡೆ close. So that is okay, denoted like this. So here x is greater than a, not equal to a, but x is less than or equal to b. Okay, so these are the elements, the real numbers in the interval, all the real numbers from a to b including b but excluding a. Next is semi closed. So these are elements, real numbers from a to b including a excluding b. Okay, yellow open barutte, that point has not considered in the interval. Okay, this is all about the basics for the topology. So now we'll come to our main definition, main topic. It is topology, that is definition of topology. So as you know the meaning of topology, okay, so what is that geometrical property? It says so that the deformation, twisting and stretching of any object, the property has to be preserved. Okay, so using the set theory we will study that one. Let x be any non-empty set. Okay, and tau, this symbol is called tau. Tau is family of subsets of x. Then tau is said to be topology on x if it satisfies the following conditions. What are those conditions? So that will given by P1, P2. So P1, the first one is empty set belongs to empty set, that is phi, that belongs to tau. Okay, so what here they are telling, x is any set, one set ಇದೆ x. So ಈ set ಮೇಲೆ family of subsets of x, ಅಂದರೆ ಇದ್ರದ್ದು some subsets ಇದೆ. Okay, so these are the some subsets of x. ಸೊ ಇದ್ರದ್ದೆಲ್ಲ ಒಂದು ಕಾಂಬಿನೇಷನ್ ನ ಒಂದು ಇನ್ನೊಂದು ಫ್ಯಾಮಿಲಿ ಆಫ್ ಸೆಟ್ಸ್, ದಟ್ ಇಸ್ ಟೌ ಅಂತ ತಗೊಂಡ್ರೆ, ಸೊ ಇಟ್ ಕಂಟೈನ್ಸ್ ಆಲ್ ದ ಸಬ್ಸೆಟ್ಸ್. ಓಕೆ, not all, it is having some family of subsets of x. ಸೊ ಈ ಫ್ಯಾಮಿಲಿ ಆಫ್ ಸಬ್ಸೆಟ್ಸ್ ಇದೆಯಲ್ಲ, ಸೊ ದಿಸ್ ಈಸ್ ಕಾಲ್ಡ್ ದ ಟೋಪೋಲಜಿ ಆನ್ ಎಕ್ಸ್. when it should have empty set. First thing is it should have empty set. Second one is set x itself is belongs to tau. Okay, that is x belongs to tau. Here phi belongs to tau. Next, third property, every union of members of tau is again a member of tau. ಅಂದರೆ ಇಲ್ಲಿ ಎರಡು ಸೆಟ್ ಇದೆ, ಇದನ್ನು ಯೂನಿಯನ್ ಮಾಡಿದರೆ ಏನು ಸಿಗುತ್ತಲ್ಲ, ಅಗೈನ್ ಇಟ್ ಶುಡ್ ಬಿ ಅ ಮೆಂಬರ್ ಆಫ್ ಟೌ ಓನ್ಲಿ. ಎವ್ರಿ ಯೂನಿಯನ್ ಆಫ್ member of tau is again a member of tau. Okay, so once we have union, next we will have intersection also. Every finite intersection of members of tau is again a member of tau. ಅಂದರೆ ಇಂಟರ್ಸೆಕ್ಷನ್ ಮಾಡಿದಾಗೂ ಅದೇ ಥರ. ಇವಾಗ ಇಲ್ಲಿ ಸೆಟ್ಸ್ ತೊಗೊಂಡಿರ್ತೀರಲ್ಲ, ಸೊ ಇಲ್ಲಿ ಇಂಟರ್ಸೆಕ್ಷನ್ ಸಿಗುತ್ತೆ, ಇದೆರಡರದ್ದು ಇಂಟರ್ಸೆಕ್ಷನ್, ಅದು ಅಗೇನ್ ಟೌನಲ್ಲೇ ಇರಬೇಕು. ಸೊ ದ್ಯಾಟ್ ಇಟ್ ಈಸ್ ಫುಲ್ಲಿ ಪ್ಲೆಜ್ಡ್ ಅಂತ, ತುಂಬ ಇದು ಇರಬೇಕು, ಆಲ್ಮೋಸ್ಟ್ ಎಲ್ಲ ಸ್ಪೇಸು ಕವರ್ ಆಗಿರಬೇಕು ಅಂತ. ಓಕೆ, ಸೊ ಹಿಯರ್ when the tau, that is family of subsets of x, having these four properties, then tau is said to be topology on x. Okay, then x tau is called topological space. X tau is called topological space. I'll explain once again the four properties. Let x is a non-empty set. Okay, tau is, it's a family of subsets of x. Then tau is said to be topology on x if it satisfies the following condition. That is, first one is empty set must belongs to tau. Second one is x belongs to, the set x itself is in tau. ಅಂದರೆ ಇವಾಗ ಪವರ್ ಸೆಟ್ಟಲ್ಲಿರೋದು ಲೀಸ್ಟ್ ಅಂದರೆ ಯಾವುದು? 5. ಓಕೆ, ಲೀಸ್ಟ್ ಸಬ್ಸೆಟ್, ಲೀಸ್ಟ್ ನಂಬರ್ ಆಫ್ ಲೀಸ್ಟ್ elements containing subset is 5 and highest is x. So these two must be in tau. And the third one is union of elements of tau. Union of members of tau is again member of tau. It is followed by ಫೈನೈಟ್ ಇಂಟರ್ಸೆಕ್ಷನ್. ಅಂದರೆ ಇವಾಗ ಯೂನಿಯನ್ ಮಾಡುವಾಗ ಎಲ್ಲನೂ ತೊಗೋತೀರ, ಬಟ್ ಇಂಟರ್ಸೆಕ್ಷನ್ ಮಾಡುವಾಗ ವೆನ್ ಇಟ್ ಈಸ್ ಅ ಇನ್ಫಿನೈಟ್ ಸೆಟ್, ಎಕ್ಸ್ ಇಸ್ ನಾನ್ ಎಂಪ್ಟಿ ಸೆಟ್ ಅಂತ ಹೇಳಿದ್ದೀವಿ, ಅದು ಇನ್ಫಿನೈಟನ್ನು ತೊಗೋಬೋದು, ಫೈನೈಟ್ ಇರ್ಬೋದು, ಇನ್ಫಿನೈಟ್ ಇರ್ಬೋದು, ಬಟ್ ಇಟ್ ಶುಡ್ ಹ್ಯಾವ್ ಅಟ್ಲೀಸ್ಟ್ ಒನ್ ಎಲಿಮೆಂಟ್ ನಾನ್ ಎಂಪ್ಟಿ ಅಂದರೆ ಅಲ್ವಾ, ಎಂಪ್ಟಿ ಇರಬಾರ್ದು ಅಂತ. ಎಂಪ್ಟಿ ಇದ್ದರೆ ದೆರ್ ಇಸ್ ನೋ ಯೂಸ್ ಆಫ್ ದ್ಯಾಟ್ ಓನ್ಲಿ, ದೇರ್ ಫೋರ್ ವಿ ಆರ್ ಟೇಕಿಂಗ್ ನಾನ್ ಎಂಪ್ಟಿ ಸೆಟ್. ಅದೇ ಇನ್ಫಿನೈಟ್ ತೊಗೊಂಡಾಗ ಇಲ್ಲಿ ಇಂಟರ್ಸೆಕ್ಷನ್ನು ಸ್ವಲ್ಪ ಇದಕ್ಕಷ್ಟೇ ಸಬ್ಸೆಟ್ಸಿಗಷ್ಟೇ ಮಾಡಬೇಕು, ಸ್ವಲ್ಪ ಫ್ಯಾಮಿಲಿ ಆಫ್ ಮೆಂಬರ್ಸ್ ಆಫ್ ಟೌ ಅಷ್ಟೇ ಮಾಡಬೇಕು, ನಾಟ್ ಫಾರ್ ಆಲ್. ಓಕೆ, ಸೊ ಫೈನೈಟ್ ಇಂಟರ್ಸೆಕ್ಷನ್ ಆಫ್ ಮೆಂಬರ್ಸ್ ಆಫ್ ಟೌ ಈಸ್ ಅಗೇನ್ member of tau only. Okay, when tau satisfying these four conditions, then tau is said to be topology on X. ಟೋಪೋಲಜಿ ಕ್ರಿಯೇಟ್ ಮಾಡುತ್ತೆ ಅಂತ. ಇಲ್ಲೊಂದು ಎಕ್ಸ್ ಇದೆ. ಓಕೆ, ಇದ್ರ ಸಬ್ಸೆಟ್ಸ್ನೆಲ್ಲ ಇದರಲ್ಲಿ ಬರೀತಾರೆ ಟೌನಲ್ಲಿ, ಫ್ಯಾಮಿಲಿ ಆಫ್ ಸಬ್ಸೆಟ್ಸ್. ಸೊ ಇದರಲ್ಲಿ ಮೇನಾಗಿ ಎಕ್ಸು 5, ಆಮೇಲೆ ಸ್ವಲ್ಪ ಸಬ್ಸೆಟ್ಸ್ ಯೂನಿಯನ್ ಮಾಡಿದ್ರೂ ಇದು ಇರಬೇಕು, ಆ ಥರ ಇದ್ದರೆ ದೆನ್ ದಿಸ್ ಈಸ್ ಕಾಲ್ಡ್ ದ ಟೋಪೋಲಜಿ ಆನ್ ಎಕ್ಸ್. ಆ್ಯಂಡ್ ಎಕ್ಸ್ ಟೌ ಇಸ್ ಕಾಲ್ಡ್ ಟೋಪೋಲಜಿಕಲ್ ಸ್ಪೇಸ್. X tau is called topological space. Okay, we'll have one example so you'll come to know better. For better understanding, we'll study by an example. Okay, so that is let x is equal to ABC, it's a set, and tau is equal to A, B, singleton set A, B, AB, and ABC 5 be the collection of subsets of X, then show that tau is topology on X. Okay, so to show we should already X and tau has given. You should check all the 4 properties P1, P2, P3, P4. So what is P1? 5 should be in tau, that is there. 5 is already in tau, so 5 belongs to tau. X belongs to tau ಇದೆ. So X ಯಾವುದು ಇದರಲ್ಲಿ? tau ಅಲ್ಲಿ ABC is nothing but X. So X belongs to tau. So P1 and P2 satisfies. Next, for P3, union of members of tau is again a member of tau. So union ಅಂದರೆ ಇದ್ರದ್ದೆರಡು ಯೂನಿಯನ್ ಮಾಡ್ತೀರಾ. ಓಕೆ, ಸೊ ಯೂನಿಯನ್ ಈಸ್ ಅಗೇನ್ ಅ ಮೆಂಬರ್ ಆಫ್ tau. ಈಗ A ಯೂನಿಯನ್ B is AB. ಓಕೆ, A union AB is AB. A union ABC is ABC. A union 5 is A. Okay, like that all the combinations you have to do. B union AB is AB. B union ABC is ABC. B union 5 is B. AB union A is AB. AB union B is AB. AB union ABC is ABC. AB union 5 is AB. ABC union A is ABC. ABC union B is ABC. ABC union AB is ABC. ABC union 5 is ABC. So with all the combinations you will get again a member of tau only. Okay, so ಇದೆಲ್ಲ ಮಾಡಬೇಕು. Then you can say P3 holds. Similarly P4. So for P4, so P4 intersection. So A intersection B is 5. A intersection AB is A. A intersection ABC is A. Okay, A intersection 5 is again 5. Okay, B intersection A is 5. B intersection AB is B. B intersection ABC is B. Okay, next B intersection 5 is 5. AB next AB intersection ABC is AB. AB intersection 5 is 5. Okay, so ABC intersection AB is AB. Okay, ABC intersection 5 is 5. So all intersections, finite intersections, of a family of that is members of tau is again a member of tau. Therefore, I'll write only one. A intersection B is 5, which belongs to tau. Therefore, P4 holds. Okay, since all the 4 properties holds, tau is called, tau is topology on X, and X tau is topological space. Okay, this is all about the topology, definition of topology.